Now let's study the multiplication properties. Just like there was the commutative property of addition, there's also the commutative property of multiplication. When separated by multiplication, the order in which the terms are arranged does not affect the product, does not affect the answer. A times B is equal to B times A, just like 2 times 3 times 5 is equal to 3 times 5 times 2. And this car picture is supposed to help remind you of the word movement. The commutative property is all about moving numbers around so that they are arranged in a different order. Let's look at one example of how we could use the commutative property of multiplication to make a problem more simplified or easier to solve. 12 times 8 gives us 96, and 96 times 5, that might be difficult to do in your head. 6 times 5 is 30, 9 times 5 is 45, plus the 3 gives us 48, so 480. I think it would be easier to change the order of the numbers and multiply the 12 by 5 first, and then multiply by 8. 6 times 8 is 48, so I know that 60 times 8 is 480. Changing the order just makes it easier for me to do this problem in my head. So think about the commutative property of multiplication. It's all about movement, changing the order of the values. Now let's think about the associative property of multiplication. When separated by multiplication, the way in which the terms are grouped does not change the product. So the key word here is about grouping. So just like there was the associative property of addition, there's also the associative property of multiplication. So in this example, I'm showing on the left that we're grouping 7 times 2 and we get 14. And 14 times 5, that's kind of difficult to do in your head. But over here, let's say you group instead 2 times 5 and you get 10. 7 times 10, that's easier to do in your head. This side, the left side, is equivalent to the right side. It's just grouped differently. Remember, associative is about who you associate with or who you are around. So this is all about who the numbers are around. And you want to focus on the fact that the grouping changes, but look, the number order doesn't. So 7 to 5 over here, it's still 7 to 5. It's just that the parentheses are around a different set of numbers. So the order of the numbers doesn't change, the grouping changes. So look at this problem. 3 times 4 is 12. And 12 times 25, I don't know, that might be difficult for you, or maybe it's not if you really know your 25s well. And then here's an alternative way to group it. You could also group 4 times 25 and get 100, and then multiply by 3 and get 300. Either way, you get 300, but you just need to know that you have the flexibility of changing the grouping to make the problem easiest for you, whatever is easiest for you to help you solve the problem. The key word here is grouping. Let's move on to the identity property of multiplication. When 1 is multiplied by a value, it does not change that value. So the identity property of addition was 0 because when you add 0 to a number, it doesn't change it. Well, for multiplication, the multiplicative identity is 1 because when you multiply a value by 1, it doesn't change it. So here's the silly example. Billie Eilish multiplied by 1, you still have Billie Eilish. So her identity did not change. Just like 8 multiplied by 1 is still 8, and -3 times 1 is still -3. So the key word here is same. It does not change the value stays the same. Here's some more examples. If you multiply a value by 1, that value does not change. The value is identical to what it was. So here's our first example. 90 times 1 is equal to 90. -7 times 1 is equal to -7. 56.3 times 1 is equal to 56.3. 3/5 times 1, it does not change it. It's still 3/5. And then I threw in this last one to try to make you think creatively. So I want you to realize that 4 over 4 is equal to 1. So if I multiply 1/2 by 1, I don't change it. So I might change how it looks. It looks like this now, 4/8, but 4/8 and 1/2 are equivalent because if you multiply by 1, you don't change the value. So 1/2 is the same as 4/8. It just looks different. So the keyword here is same. And now we're going to add to the notes that you already had. So you already had notes on addition, and we're going to add to them. So here's our next example. For multiplication, you're going to add this example. So the keyword is still movement. We don't have to write that again. We're just going to add this part, the commutative property of addition and multiplication. And then we're going to add a multiplication example so that we have an addition example and we have a multiplication example. And then for the associative property of addition, well, it's the associative property of addition and multiplication. And here's our example for the multiplication. So you're adding these things to the notes you already have. Then we have the identity property of addition, and there's the identity property of multiplication. Here's an example, 8 times 1 is equal to 8. The keyword is still same, so I'm not going to write that again. And we need to add that the multiplicative identity is 1. So pause this, take those notes, and then we need to take notes on this next part, the distributive property. We're going to keep all of this the same. We're just going to add one more example because the distributive property works over addition and it also works over subtraction. Please take good notes so that you have something to reference as you try the next example problems. It will help you to be able to identify the different properties.